This is lesson 53 from Saxon Algebra 1. We're going to start by talking about the power rule for exponents. I'll write that out so we know what we're talking about. So in some previous problem sets, there have been some problems whose solutions have required the use of one or more of these definitions and theorems that you see written here. So the first one was looking at x times x times x times x, any number of times, will equal x raised to how many times you had it listed there. So that's just talking about what exponents are. The next one is the product rule of exponents. When you have x to the m power times x to the n power, you can say it's x to the m plus n power. So I'm going to show you an example of that one over here. So if you had x to the third power times x to the second power, that would be x to those two powers added together, the 3 plus 2. So it would be x to the fifth power. So it's just saying when you have the same base, you can rewrite that base and you're just going to be adding those two exponents when these are multiplied together. The next one is, this one's an easy one to remember. Anytime something is raised to the first power, it will just equal itself. The next one is when you have something raised to the negative power, you can get rid of that negative exponent by moving the whole piece to the other side of the fraction bar. So since it's technically in the numerator here, if you move it into the denominator, you can make the exponent positive or change its sign. The next one here is x to the 0 power. No matter what x is, it'll always equal 1 when it's raised to the 0 power. And again, when I say no matter what x is, that's keeping these in mind that x cannot equal 0 in a lot of these situations. And then the last one is the quotient rule. So when we saw what happens when you multiply things with the same base with an exponent, but when you divide them, you do the opposite. Instead of adding those exponents, you divide them. So here's an example of this one. If you have x to the fifth power divided by x to the second power, you have x, and then you subtract the top to the bottom, so 5 minus 2 is 3. And you can even see this written out. If I have x to the fifth power, I can rewrite that as x times x times x times x times x. So I have 5 x's up top, and x to the second power can be written as x times x. And we can show that this is x to the third because I can cross out these two x's and these two x's, and I'm just left with 3 x's up top, which makes x to the third power. So these are some of the rules of exponents. So to complete the list of rules for exponents, we're going to introduce the power rule. So this is the one we're talking about today, and we're going to write this one down here. The power rule is what happens if you have x to the fifth, for example, and you raise that whole thing to another power, like to the third power. So in this case, they're going to make a point to show you this isn't just saying we need to multiply the 5 and the 3. We only multiply those when we have the same bases and they each have an exponent. But here, when it's raised to this power, that's the same thing as saying x to the fifth times x to the fifth times x to the fifth. So that's the cubed part. I wrote that 3 times because of that 3 right here. So that really equals, because of our product rule here, we can add those 3 exponents, so it becomes x to the 15th power. If you look up the relationship of that 5 to the 3, is if you multiply 5 times 3, you get x to the 15th power. So that's what the power rule is. The power rule says x to the m power raised up another n power will equal x to the m times n. So I'm going to show you a couple more examples of this. Let me scoot this down. So if you have a to the 5th power and raise that to the 2nd power, all you do is multiply the 5 times the 2 to get a to the 10th power. If you have 4 raised to the, not 4. If you have x to the negative 4th, I just went ahead and wrote it wrong. And if you raise that to the negative 2 power, we just rewrite our base and we just multiply these two exponents. The negative 4 times the negative 2, because they're both negative, it becomes a positive 8. So that's all you do is multiply those exponents. So let's do another example problem. I'm going to find one further in so that I'm showing you one that they might give you later. Let's say you have 4xy over m to the negative 2 power, and we're going to raise all of that to the 2nd power. So we need to essentially distribute that squared into each of these terms. So the first thing I'm going to do is make 4 squared, then I'm going to make my x squared and my y squared. So I sort of distributed that in to each thing there. And now, because I already have an exponent down here of a negative 2, I need to multiply that by this positive 2. So this m, instead of just being to the negative 2 power, it now becomes the negative 4 power, because I'm multiplying this negative 2 times the positive 2. And then the last step in this is to actually apply this squared to the 4 and turn it into 16 x squared y squared over m to the negative 4th power. So it's just making sure that any time you have a power raised to another power, you're multiplying those two together. The other piece they're talking about in lesson 53 is converting volume. So volume conversions. So we've talked a little bit about unit multipliers before, but a unit multiplier, just as a review, is when you take two things that are equal to one another. So I can write any number over another number and it's going to equal 1. I can write 1 over 1. I can write 382 over 382, and those all equal the number 1. Well, I can also do that with measurements. So if I know that 12 inches is the same thing as 1 foot, it's like I'm writing the number 1. So I can multiply this fraction, because this fraction really just equals a 1, I can multiply it by any number without changing the value of that number. And that's what allows us to do these unit conversions. But if we're converting volume, volume is different than a lot of things, because volume involves cubic measurements, because we're not just measuring the area of something, we're also measuring the depth of something. If you're finding the area of something, you're multiplying one side times another. Oops, sorry about that. You're multiplying one side times another when you're finding area, but when you're finding volume, you're also creating the depth of it too. So it's like cubic measurements. It's kind of times 3 things. So when we convert volume conversions, we're taking units and multiplying them basically 3 times together. And I'll show you what that means in an example. They want us to use unit multipliers to convert 180 feet cubed, and they want it to end up in cubic inches. So we're starting with cubic feet, and now we have to end up in cubic inches. Whenever I convert anything, whether it's volume or anything, anytime I'm using unit multipliers, I put my original thing over 1, just to remind me it belongs in the numerator. Now, again, I can take that and multiply it by 1 all I want without changing the value of it. And my unit multiplier to convert a foot into an inch is this unit multiplier we were using as an example up here. 12 inches equal 1 foot. So I can write that as 12 inches over 1 foot, or I can write it as 1 foot over 12 inches. I want to choose the one that makes my feet cancel out. So I want feet to be in the denominator. So that means my inches will be in the numerator. So I have 12 inches equaling 1 foot. Now, if I multiply these together, I have feet cubed here. That means I need to have 3 feet cancel out, which just means I need to rewrite this 3 times. So there's the second one. And here's the third one. So I had feet cubed up here. Now I have feet cubed in my denominator. So when I multiply this, all 3 of these feet cancel all 3 of these feet. And in the end, I am left with 180 times 12 times 12 times another 12. But my units now are inches, and since I have 3 of them, I could just write inches cubed. Now this is often how your book will leave the answer. You can put those numbers in your calculator if you want to find the exact answer, but they leave it this way so you can really see what you are multiplying together to get each answer. So that's just a little bit about volume conversions. The main thing is looking at your units and deciding how those can cancel out, and making sure when we're dealing with volume or things cubed that we use 3 unit multipliers to change that to our new conversion. All right, let me know if you have any questions about lesson 53.